Hello everyone, welcome to lecture 1.2 of testing of hypothesis large sample. In this lecture, we are going to do two problems under the topic test for significant difference between sample mean and population mean. Now we'll go for the topic. A test was given to a large group of boys who scored on the average 64.5 marks. The sample test was given to a group of 400 boys who scored an average of 62.5 marks with a standard deviation of 12.5 marks. Examine if the difference is significant. So it is given the large group of boys scored average 64.5. So this is a population mean 64.5, that is mu is equal to 64.5. The group of 400 boys, so this is a sample size, n is equal to 400, which is greater than 30, therefore it is coming under large sample, and the average of that sample is 62.5, that is x bar is 62.5, and the standard deviation of the sample is 12.5. So it is the standard deviation of the sample, which is S, 12.5. Examine if the difference is significant. So now we are going to check whether this sample come from this population or not. That is, we are going to test the significant difference between the population mean with the sample mean. Therefore, this problem coming under the topic test the significant difference between the sample mean and population mean. So first step, we are going to write the given data. So what are all the given data? Usually we'll write first N1. Here only one sample we have. So N is equal to 400, and the average, the mean of the sample x bar is equal to 62.5, and the standard deviation of the sample S is equal to 12.5, and the mean of the population mu is equal to 64.5. Okay, so here in the previous problem, sigma is given, the population standard deviation is given. Here the sample standard deviation is given, that is the difference. So now we have n, x bar, s and mu. We are going to write h naught. H naught is always equal to, something is equal to something. Here we are going to check the mean. Is there any difference in mean or population mean with sample mean? So here we'll write always the population parameter, which is mu, which is here 64.5. If it is true, then we can conclude that the sample come from the population with mean 64.5. Next, H1, which is alternative hypothesis. So here the question is, this sample come from this population or not? So we'll write mu is not equal to 64.5, which is two-tail test. Therefore, it is under two-tail test. Now we are going to write the third step, that is the test statistic. X bar minus mu by, if sigma is known, then we'll write sigma here. Here sigma is not known. Instead of sigma, we have S. So S by root of n, which is equal to x bar is 62.5 minus x mu is 64.5 by S is 12.5 by root of 400. Now we'll find the value. First put the numerator bracket 62.5 minus 64.5 5, close the bracket, divided by, open the bracket for the denominator. It is 12.5 divided by square root of 400. Close the bracket. So now we are getting minus 16 by 5. So if you find the decimal point, it is minus 3.2. Minus 3.2 is the answer. Minus 3.2. So here it is two-tailed test. The calculated value Z is equal to minus 3.2. Usually we want mod Z, which is equal to modulus of 3.2, which is equal to 3.2. This is our calculated value. Now we'll write the table value. Here the level of significance is not mentioned, so we will take 5% level of significance. So at 5% level of significance for two-tailed test, the table value is 1.96. So the calculated value 3.2, which is greater than 1.6. The table value, the calculated value is greater than the table value. Therefore, H0 is rejected. So the conclusion is this sample is not coming from the population with mean 64.5. So H1 is accepted. H0 is rejected. Therefore, H1 is accepted. Hence, the difference is significant. So the sample is not coming from the population with mean 64.5. That is a conclusion. Next problem. A sample of 100 people during the past year showed an average lifespan of 71.8 years. If the standard deviation of the population is 8.9 years, test whether the mean lifespan today is greater than 70 years. So, what is given? We have 100 people during the past year. 100 people during the past year showed an average lifespan of this. So, this is our sample size. N is equal to 100, which is greater than 30. Therefore, large sample. And this is the mean of the sample. If the standard deviation of the population sigma is 8.9, test whether the mean lifespan today is greater than 70. So the question is, the population mean is 70 or greater than 70 is the question. So population mean is 70 is given. So now we'll first write the given data. N is equal to 100, and then X bar, the sample mean is 71.8 years, and then the standard deviation of the population is given, which is sigma, which is equal to 8.9, and mean of the population is mu is equal to 70 are given. Now we are going to check whether this population mean is greater than. Test whether the mean lifespan today is greater than 70 or not. That is the question. So our H0 already you know it should be always equal to, and here we should write the population parameter mu, which is equal to 70, and H1 it is given the today is greater than 70 or not. So mu should be greater than or not equal to. So mu is greater than 70 is our H1. Next, we'll go to third step. Write the test statistic formula x bar minus mu by sigma by root n, which is equal to x bar is 71.8 minus mu is 70 by sigma is 8.9 by root n is 100, which is equal to 2.202. 2.02. So our Z is 2.02. Already here we have greater than, so it is one tail test and a right tail test. It is right tail test. Here the degrees of freedom, the level of significance is not mentioned. So we will consider 5% level of significance. So the table value of Z at 5% level is 1.645. The table value of Z at 5% level is 1.645. So calculated value Z is 2.02, which is greater than 1.645, which is our table value. Therefore, H naught is rejected. If H naught is rejected, then H1 is accepted. Therefore, mu is greater than 70. So what is the inference? The mean lifespan today is greater than 70 years. That is the answer. This is our inference. Thank you.